Welcome back to another Daishinfinity video. In this video, we're going to prove the addition theorem of cosine, which states that cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. We're going to use this by proving by using the Euler identity formula or the Euler's formula stating that Euler e to the I alpha or e to the I theta is equal to cosine theta plus I sine theta. And alpha minus beta sounds like something where it's a subtraction or a difference of two angles, but it's called addition theorem since alpha minus beta is just equal to alpha plus minus beta. So now we're going to try and prove it using the Euler formula. Now we have e to the I theta equaling cosine theta plus I sine theta. For the proof, maybe in another video. Now we're going to use this as f of x, and we're going to let it be equal to f of x since every function f of x or f of theta can be demonstrated as 1/2 times f of x, so the even function f of x plus f of minus x, or f of minus theta, plus 1/2 times f of theta minus f of minus theta. And since we have the addition of two functions which equal a function, since the first part and the second part are even and odd functions, we know that cosine of theta is equal to cosine of minus theta. And since this is true for every theta from 0 to 2 pi, and so we can tell that cosine of theta is the even function. So we're going to tell that cosine of theta is 1/2 times the e to the I theta plus e to the negative I theta. Since e to the I theta, we have let e to the I theta be equal to f of theta. And since we don't have theta, we have alpha and beta, we are going to write cosine alpha minus beta is equal to 1/2 times e to the alpha minus beta plus e to the negative I times alpha minus beta. And since we have those, we can use a product or the exponent rule to make it into two e to the I alpha, e to the I beta products, which states that we have 1/2 times e to the I alpha, e to the negative I theta, beta, plus e to the negative I alpha, e to the I beta. Now, we can use every single Euler with the alpha and beta, and then write it as the Euler's identity, stating that, for example, e to the I of alpha is equal to cosine alpha plus I sine alpha. So we will write cosine alpha plus I sine alpha, and since e to the I and negative I beta is, if we look at the complex plane, it's just a conjugate of the complex number e to the I beta, since since the angles are just a negation of it. And if you really would look at the graph, I'm just going to plot the graph right now with the complex number z and the conjugate z, then the angle theta that is here is theta for the z, and the conjugate is minus theta. And if you look at the sides of the triangle that we can see by every vector that is created, then the first side is the absolute value of z times cosine theta, and the second is absolute value of z times I sine of theta. And since the conjugate has negative theta, we have to say that we have sine of negative theta, but since it's an odd function, it's minus sine of theta. And since that is the case, we can say that we have cosine beta minus I sine beta plus cosine alpha minus I sine alpha times cosine beta plus I sine beta. And then now we have four parentheses, we just have to work on them, just expand them. So we have cosine alpha cosine beta. And then after cosine alpha cosine beta, we would have cosine alpha times minus I sine beta. And then I sine alpha cosine beta. And then I times I is -1 times -1 is +1, so plus sine alpha sine beta. And that is the first parentheses. So no, the first two. And since we have the first two expanded out, we can expand the second two parentheses and then write them as a sum of many, many cosines and sines. So we have cosine alpha cosine beta plus I sine beta cosine alpha. And I'm just going to write cosine alpha just below the I sine beta. Then minus I sine alpha cosine beta. And then minus I times I is just plus, so plus sine alpha sine beta. Now we are done with everything. We have done with expanding everything into many, many little parts of cosine and cosine alpha, cosine beta, sine alpha, sine beta, and i's. And now we're going to eliminate some of them. So we can see that cosine alpha, cosine beta is twice, and sine alpha, sine beta, we can also see it's twice. So we can put them together. And then if you look at the i's, I sine alpha cosine beta will cancel out with the negative I sine alpha cosine beta, and the I sine beta cosine alpha will also cancel out with the negative I sine beta cosine alpha. So at the end we would have 1/2 times 2, so I have made a mistake, 2 cosine alpha cosine beta plus 2 sine alpha sine beta. And since we have two of them, and we have the 1/2 in the front of the parentheses, we can cancel them out, and then we would have that cosine alpha minus beta is just equal to cosine alpha cosine beta plus sine alpha sine beta. I hope you really enjoyed this video. If you liked this video, like and subscribe, and we will see us in the next Daishinfinity video. See ya.